Hi everyone, here we go with another problem which says that the scattering potential, which is central because in the problem statement the vector is not mentioned. For the sake of understanding and having an idea, I'll attach one of the problem statement for the non-spherical potential or non-central potential. So here the potential is central, and we can say the vector is not there, and this is a function of r only, hence this is a central potential where v naught is a constant quantity, a is constant, and r is variable. We need to calculate the differential cross section using Born's first approximation, and we need to find out the relationship between v naught, a, k, and mu, such that the Born approximation is valid. And thirdly, we need to calculate the total cross section. So for the first part, since this is a spherical potential, so here is the potential. Now we are since this is a spherically symmetric potential, we'll use the formula for spherically symmetric potential, and that is easy for us. Okay, now we are putting the value of potential right there, which is v naught e to the power minus r by a sine q r prime dr. Here v naught will come out of the integral minus r by a, and these are all in prime coordinates, okay, because it requires it, and well, it doesn't make that much difference if okay. Now sine qr prime, if we know the Euler's identity, then sine qr prime can be written as e to the power iota, then its angle, which is qr prime, minus e to the power minus iota, this angle qr prime, divided by 2 iota. So I'm plugging this value of sine qr prime right there to make the integral evaluation easy, okay. So because if we take sine qr prime e to the power minus r prime by a and r prime, the integration will become a bit lengthy. So that is why I'm plugging this value right there, and dr prime as it is, and some more simplification, 2 iota will come out of the integral, and here I'm multiplying this quantity with this and this with this, okay, and I'm separating the integral into two parts being separated with each other because the negative sign is there. So negative 0 to infinity r prime, firstly this term will come and negative sign, and then the another integral will come with this. Okay, now we need to find out this. Before we do this, we need to add these exponents together because the bases are same, so we can further make it easy for us. 2 and 2 gets cancelled out, so this is minus mu v naught h cut square q. So the powers will add. I'm taking minus r prime common, okay. You have to take minus r prime common because when we'll put the limits of integration, it's infinity. So if you take r prime as common, okay, from this whole quantity, then it will become challenging for us to show that it will not diverge, okay. Because if you take e to the power minus r prime and some constant quantity inside, then when you will put infinity in this place, then it becomes e to the power minus infinity, and e to the power minus infinity is 1 over e to the power infinity, and e to the power infinity is infinity, so 1 over infinity comes, and 1 over infinity is 0, so this becomes converging. So to avoid the problem of convergence, we are doing it, okay. So if it had been a minus infinity power, then we would have taken r prime as common. So I hope the point is clear. So I'm taking minus r prime common, and the thing that is left behind is 1 over a, okay. plus iota q. I'm from future and it is minus iota q, because you can see that above here the signs are opposite. So if I take negative as common, then the signs will be inverted. So previously the sign of iota q exponential part was positive, so it will become negative in exponent. Iota was not there with this sign, so iota will not come common. So here negative mu v naught h cut square qi iota is left. 2 was cancelled out, so I was doing we were adding the power. So I'm taking minus r prime as common, and 1 over a, since the signs are opposite to each other, here it is plus iota q, and if I take negative r prime as common, so the thing that will be happen here is the signs inside will be inverted. So 1 over a will come with positive sign, and this will come with a negative sign, and dr prime, okay, minus r prime 0 to infinity. The similar thing will be happened here, since negative sign is with both of these quantities, so the thing that will be left behind will be simply with the positive sign only. Inside the quantities there will be positive sign, and here we go with closing the brackets. Here we took minus r prime as common because here the limit is infinity, and if we do not take r minus r prime as common, then we will be left with r prime in some constant quantity. Let's say this is d. So if we put the limits of integration in the future, we will surely get this exponential term in the solution. So if we put upper limit as infinity in place of r prime here, so it will become e to the power infinity, which is infinity. So there will be some convergence problem right there. So that is why we took minus r prime here, because the problem of convergence will be solved in that case. Because if we put here infinity in place of r prime, then we will get e to the power minus infinity, and e to the power minus infinity is equals to 1 over e to the power infinity if we place it down in the denominator, and e to the power infinity, since it is infinity, so we will put 1 over infinity, and 1 over infinity is 0. So the problem of convergence will be solved. The limit of integration was from 0 to infinity, that is why we did it. If it would have been minus infinity to 0 limits of integration, then we would have taken r prime as common. Okay, so depending upon what kind of integral you are encountering, you will do these kinds of things to avoid the problems in future. So here now the time has come to do the integration by parts. We will take this as first quantity and this one as second quantity. Whenever this kind of configuration comes, we always take this thing as first term and this one thing as second term in priority type wise. So first term as it is, we are writing the integration of this term first, then we'll write the integration of this one term. So first term as it is, integration of second term. Integration of this term is, we know already, that is why we will write it directly. This term as it is divided by the derivative of its power, which is negative 1 over a minus iota q, minus integration derivation of first term, which is r prime, and this is dr prime by dr prime, which is equals to 1, you know. So we'll write 1 here, and integration of second part, which is this, and dr prime. Here we have wrote the integration of this part. Now we'll do the same thing for this one part. Here the negative sign comes in, so I'm using bracket here because the negative sign will be multiplied with each value that comes up for this integration. So first term is this and second term is this. First term as it is, integration of second term and its integration is 1 over a plus iota q, this is as it is, and minus 1 over a plus iota q, minus derivation of first term, which is 1, and again integration of second term enclosed by another integration, this. Okay, now I am multiplying this negative sign with these quantities so that one more step is reduced. So this negative sign multiplies with this and it will make it positive, so this one positive sign with it and I'm removing the bracket, and negative sign will multiply with this to make it positive also. This negative sign is still there. So r prime negative sign e to the power minus r prime 1 over a minus iota q minus 1 over a minus iota q. Limits of integration 0 to infinity is still there on the whole this integral thing. This negative sign and this multiplies and becomes positive, and we can take 1 over a minus iota q outside the integral. So 1 over a minus iota q integration e to the power minus r prime 1 over a minus iota q dr prime plus this one quantity and plus minus minus, and 1 over a minus iota q and integration minus r prime 1 over a plus iota q, and limit of integration 0 to infinity on the whole integral. And one more, this integration is left, which is easy. This negative sign cancels out with this and it becomes positive. Here its integration will be again minus r prime 1 over and negative of 1 over a minus iota q. I am taking negative as in brackets so that you may not confuse it with, or anyone may not confuse it with, like as if they are being subtracted from each other. That is why, to avoid that kind of confusion. So its integration will be minus r prime 1 over a plus iota q and 1 over a minus, oh, it's plus here. I wrote it minus by mistake. Okay, it's plus, and minus 1 over a plus iota q. This term as it is, and the derivative of its power being divided to this. So in the next step, I'm just going to put the limits directly. If we take consider the upper limit, which is infinity, and if we put infinity in all these terms, we can see that the each terms include the exponential term at least. Okay, so if we put the upper limit, then the exponential term in all these quantities will become e to the power minus r prime some constant. Okay, this is the same configuration. If you put the upper limit, which is infinity, it will become like that, which is 0, I told earlier. So this whole all integrals will become 0 for infinity, and this will not create any problem. Like this is not like infinity times some 0 thing, because when we have the exponential functions, then the exponential functions are always dominant function, because the configurations like that, like x e to the power x, for example, like that, if we put x, if we increase the x as large as like 440, then x is 440 and it is finite. But if you find out e to the power 440 in negative sign, because it is all negative, then you will see that this quantity is 0. In calculator you can confirm it. So even when the x is not has not become very large, but exponential function has already become 0 very long ago, before even the infinity is reached. Okay, this is not a very big quantity. If you put e to the power minus 1000, it is 0. All of the higher powers are 0. So the exponential function makes the function 0 very earlier than this could make it infinity. So that is why for the very large powers, exponential functions are dominant function, and we approximate the limit by putting the things like very large values in exponential parts. So all of these integrals will become 0 for the upper limit, because all of them involves the same exponential function, which is 0 for e to the power minus infinity. So they are all 0. So only low limits are left. Now for the low limit part, you can see when we put 0 in place of r prime, this integral becomes 0, because here r prime is 0. Okay, this will make the whole quantity 0 for the lower limit, and this integral will become 0 also, because r prime is there too, but these two will be non-zero only. Okay, so upper limit is 0 minus lower limit, which is this quantity, this negative sign comes up, and e to the power 0, because this 0 multiplied with the whole quantity makes the exponent whole 0. So 1 over a minus iota q whole square, because both of them are same. And here it is a negative sign. This negative sign and this negative sign cancels out and becomes positive, and e to the power 0 for the lower limit, and 1 over a plus iota q whole square. Now this negative sign is common for both these quantities. When multiply with this quantity, it becomes positive, and it is minus 1 over 1 over a minus iota q whole square, which is plus 1 over a plus iota q whole square. Now the next step is to take the LCM, and during the LCM it will give us 1 over a minus iota q whole square, which we will simplify further. Okay, and the LCM becomes minus 1 over a plus iota q square plus 1 over a minus iota q whole square. Now we need to open up this whole square thing, and we can simplify this quantity also. Q iota, and I'm opening the square, so 1 over a plus iota q, which is 1 over a square plus iota square q square, a square plus b square plus 2ab. So here, okay, the formula I'm using here is, I'm writing it in x and y format so that you are not confused with a that is written here, x square plus y square plus 2xy. And another formula that we'll use here is x minus a into x plus a is equals to x square minus y square. This is the formula that we'll use in denominator simplification, and this is that we use in numerator. So plus sign, and I have opened up its square. Now I'll open the square of this quantity, and which is 1 over a square plus iota square q square minus 2 iota q by a. Okay, in division sign we have the squares of these two quantities. Okay, and the squares of these two quantities can be split it up, like the square means that the thing is coming two times being multiplied with each other. So I have just splitted the squares, and you can see there is one pair and there is another pair. So we can write them as x minus y into x plus y, which is equal to x square minus y square. The same thing will happen with this, and both of them will result the same quantity. So let me write it. I'm multiplying the negative sign with these all quantities. Iota square, there is no need to put the value of iota square because like it will be cancelled out now. Plus 1 over a square iota square q square. Okay, negative sign was only with this quantity, so this will cancel out, and in the denominator we have a square 1 over a square minus iota square q square for this one pair and also for this one pair. Under the influence of this formula, you can multiply them in order to confirm, okay, these two pairs and this one pair. And we got here minus 4 iota qa. Okay, and in the denominator we can take the square of these two quantities because both of them are same, and the 4 will come out, iota and iota will get cancelled out, this q and q will get cancelled out. 4 mu v naught by h cut square a, and with negative sign, and 1 over a square iota square is equals to minus 1, so it will multiply with this minus sign, it will become positive, a whole square. And that is the final result for the scattering amplitude, and we will take the square of it because it is a real quantity. We need not to take any square conjugate, complex conjugate, etc. things. So d sigma by d omega, which is differential cross section, is equal to the square of this quantity, which is 16 mu square v naught square h cut 4 a square 1 over 1 over a square plus q square power 4. Okay, this is the differential cross section. You can confirm if there is negative here or not, if I made any mistake, or even if it is there, the differential cross section, since it is the square of it, it will not be affected. So this is the differential cross section. One is done. Now we need to calculate the part B and then the total cross section part C. Now for the part B, we need to find out the condition for the validity of Born approximation. This is the condition, and we need to calculate this integral, and this integral is what decides the condition. So I'm letting this as to be equals to I dr prime. V of r prime we know is equals to v naught e to the power minus r by a in prime form, then e to the power iota 2k r prime minus 1 dr prime. Taking v naught outside the integral and multiplying this with both these quantities, we got okay. When it this thing will multiply with both of these quantities, the integral will be distributing among them. This multiplied by this and this multiplied by this, and this one comes in, and I'm adding again. I'm doing the same thing. I'm taking minus r prime common, and it is 1 over a minus iota 2k inside left, and the integration of this part is equals to e to the power minus r prime by a over 1 minus 1 over a derivative of power, and integration of this thing is 1 over a minus iota 2k with negative sign. This negative sign cancels out with it, and it is e to the power minus r prime by a. This is 1 over a, it jumps out and cuts over in numerator. Now I will put the limits, and for the limit infinity, these two are 0 for the same reason, because r is infinity, then e to the power minus infinity is 0. For the upper limit part, they both are 0, but the lower limit part, they will be non-zero. And for this, I'm putting upper limit minus into lower limit, and this will be e to the power 0 over minus 1 over a minus 2 iota k plus a e to the power 0. This negative sign will multiply with both of these quantities. It will make it 0 positive 1 over a minus a, because e to the power 0 is 1. So v naught, if I take LCM of this quantity, it will become 1 over a minus 2 iota k minus a. So this is the expression that we got for this integral. We will plug this value right there, and this is finally the condition. Okay, so I'm plugging this value into this expression simply, and it becomes v naught 1 over a minus 2 iota k minus a, and in denominator it is 1 over a minus 2 iota k mod, and this is very less than 1. Okay, this is the condition. Now for the part C, we need to find out the total cross section, and for this we need to integrate the differential cross section that we got. So the differential cross section that we obtained was 16 mu square v naught square h cut 4 a square okay. We need to find out the total cross section. For this, we will take this in this here, integrating now both sides. So it will become total cross section, and that is equals to integration of this quantity, and taking 16 mu square v naught square h cut 4 a square. All of these are constant, so I'm taking them out of the integral, and here we are left with 1 over a square plus q square 4. Here q is the variable. Okay, here q is equals to 2k sine theta by 2. So here k is constant and theta is variable right there, so we'll put this value, and d omega is equals to sine theta d theta d phi. Okay, so there will be two integral because there are two now differentials. For theta differential it is 0 to pi maximum limits and 0 to 2 pi for d phi. Since d phi there is none value which depends upon phi, so we'll write it separately and simply solve it. And theta dependence is there for the q, that is why we'll write it here. Q square is 4, k square will take square of this, 4k square sine square theta by 2, and here sine theta d theta. Okay, 16 mu square v naught square h cut 4a square. This integral solves out to give 2 pi. The integration of d phi is phi. In limits of integration are 0 to 2 pi, upper limit minus lower limit, so 2 pi is the result. And here, and we need to calculate this integration. Here power 4 is there. For this we need to make some substitution to make it easy. So I'm substituting this quantity 4k square sine square theta by 2 as to be equals to, let's say, x. Okay, so now we need to take the differential on both sides, so 4k square as it is, differentiation of sine square theta by 2 with respect to x, so it will be 2 power rule sine theta by 2 dot derivative of inner term that comes inside the square, that is sine theta by 2, which is cos theta by 2. And when we do the derivative of sine theta by 2, it becomes cos theta by 2 multiplied by the derivative of its angle, which is 1 by 2 now, and that is equals to d theta equals dx. Okay, so we took the differential on both sides. Now we need to find out the value of d theta so that we can plug the value of d theta in the form of x. So for this 4k square, now 2 sine theta by 2 cos theta by 2 is equals to sine theta. Okay, this is double angle formula for sine 2 alpha is equals to sine 2 sine alpha cos alpha. So here alpha is theta by 2, so if we put theta by 2 in place of alpha, 2 and 2 cancel, so this quantity equals sine theta. So I put sine theta right there with 1 over 2 that comes out, and d theta is equals to dx. So sine theta d theta equals dx, 2 and 2 cancel, 2k square, and it comes right there, and it is 2k square dx by 2k square in place of this quantity. And limits of integration will be changed too, and we will use this expression to find out the, for the low limit theta is equals to 0, we will find out, since it is equals to this, for theta is equals to 0, low limit of x will be obtained, and x equals 4k square sine of 0, okay, sine square of 0, which is 0, so multiplied by 0 is 0, so low limit is x is equals to 0 in form of x, and theta is equals to pi is the upper limit, and if we put upper limit in this expression, we will get the upper limit of x 4k square sine square pi by 2. Sine square pi by 2 is 1, so we get 4k square as upper limit. Now I am substituting all these quantities into this integral. Here is the substitution that I will make now, and we successfully found these values in place of all this stuff. So I'm putting these values now. And limits become 0 to 4k square, and in place of sine theta d theta it will be dx by 2k square. Now I'm writing 2k square in denominator outside the integral because it is constant quantity, and in denominator 1 over a square plus I didn't record it, I can't believe it. We wrote it like that. Okay, the next step is to take the integration, and to solve the integration, and I wrote the same thing here. 2 and 2 gets cancelled out. Okay, and the rest of things are written right here, and the integration of this is simply the power rule. I'm using the power rule. 1 over a square plus x, I'm taking it in the numerator, which is -4. It will become -4, and then using the power rule, -4 plus 1, -4 plus 1. This is simply the power rule, and limits of integration from 0 to 4k square as it is. In the next step, I have solved this power thing, and -4 plus 1 is equals to -3, and -3 in the denominator, which comes out here. Okay, which comes out here. Rest of the things are same as it is in here, and 1 over a square plus x to the power to the whole power -3, and in next step I put these values right there, and in place of x the upper limit is 4k square, and in place of x here the lower limit is 0. So here it is upper limit 1 over a square plus 4k square whole power -3 minus lower limit in this thing. So in the next step we are writing minus 16 by 3 mu square v naught square pi by h cut 4 a square k square, and 1 over a square plus 4k square to the power -3 minus 1 over a square to the power -3. Okay, now now it will come in the denominator, and the power will become positive, minus 1 over a square to the power 3. Now I am taking 1 over a square to the power 3 in the denominator as common from both these quantities. So it will become 1 over a square to the power 3 is taken common from both these quantities, and the thing that is left here is 1 plus 4 k square a square to the power 3 minus 1. Okay, because this whole quantity gets out, and when you take common 1 over a square to the power 3, because if I explain this step, 1 over a square plus 4k square. Okay, now if I take 1 over a square common from it, it means I'm multiplying a square inside, okay, with each quantity. This quantity cancels out, that is why it is 1 plus 4k square a square, because the whole these thing is inside the cube power, that is why q will appear on it and appear on that too. So it is 1 over a square to the power 3 that is taken common in the denominator. Okay, I hope now it's clear. This whole thing is happening in the denominator. Now this is 1 over a to the power 2 with cube, so 2 3s are 6, so and I'm multiplying this negative sign with these two quantities so that here is positive, so 1 with positive sign minus 1 over 1 plus 4k square a square to the power 3 whole power 3, and this a square cancels out with this, and the 4 power is left. 6 minus 2 is 4, that is why, and this a4 jumps to the numerator because it is 1 over a4, so it jumps to the numerator and it becomes so this is the final answer that we got for the total cross section.